All right, so the very last thing that we're going to do for this week, and it is percents. And I know some of us really struggled with that, with this when we did it, but that's okay. Before we get going out, there are a few things I want to talk about percents. Something that should help you is think about the percents on your phone, right? The percent of your battery. Okay, the percent is basically a fraction. Okay, it's a fraction that tells us how much of something is up the part, right? So we're comparing the part to the whole, and that is really, really important when we're talking about percents, is what's the part, what's the whole, and then which one are we trying to find, okay? The percent tells us what fraction of that is equivalent, basically, okay? So percents are really just equivalent fractions, and I know that they sound scarier, but it's really just an equivalent fraction. So let's take a look first at, this is the example that you should have in your packet. This is page number 31 of your packet if you wanted to take a look at that. Okay, page 31. So when we're taking a look at percents, I want us to first talk about what a percent is. So if I told you, for example, 40%, right? We talked about in class how we could write that as both a fraction and a decimal, right? 40% tells me percents are always out of 100, right? So this tells me that there are 40 out of 100%, okay? Out of the total of 100. 40 is the part, 100 is the whole when we're talking about a percent. As a decimal, this is the same as 40 hundredths, right? Literally, my fraction is 40 hundredths. So this is the same as 40 hundredths as a decimal. That's something good to keep in mind. Now, when we take a look at this first example, it says in an after-school sports program, 70% of 400 students play soccer. How many students play soccer? Okay. Now, that's a lot of soccer players, 70%. Okay. So I want to know the part, right? So it says 70% of the 400. This is the really, really important thing. In this case, 70%, right? That's basically the fraction, right? That's the percent that we're looking at. The part of the students, it tells me how much of the students. It's not the part, but it tells me how much, the fraction of students. 400 is my whole, okay? 400 is all of the students, right? 400 is the total. We care about that whole, and I want to know what part, literally how many of the students are playing soccer, okay? They gave you this nice little table here, or this picture here. It's basically a double number line. Okay, if I wanted to look more like a double number line, I could say that this is 40, 80, 120, right? I could add that up. They're saying each box is worth 40. Every time I go up a new line, it's worth 40 more. That's all they're doing. So I could go ahead and label this all the way up. We know that 400 is the same as 100%, right? 400 is my whole, 100% is a whole total battery, right? So we're thinking about it like that. I could even make it look like a battery if I wanted to, okay? Just like the battery on your phone, 100% charged. So I want to know what we're trying to find is 70%, right? I want to know what number is equivalent to 70%, okay? So I can do a couple of different things here, okay? You can use this double number line diagram where you can say, okay, well, 70%, right, is just 7 parts of my total, right? If I split this up into each little part is 10%, right? So I can divide my 400 total by the 10. That's how they got 40 in each box, right? That's where this little 40 came from inside of the box. So then I can say, well, 70% is going to be 7 of those 10% boxes. So I can do 40 times 7 boxes, which is going to give me a total of 280 students that play soccer, okay? That's how you can use your double number line diagram. Ooh, tongue twister there. Okay, the other way that you could look at this, and I'm gonna kind of draw a little line here. Another way that you could think about this is, if it is 70% of 400, think to yourself for a second, what does of mean? When I see the word of, what operation am I doing? Okay, you should know this. When we see of, that means that we are multiplying. So the easiest way that I do this is this is 70% of means times my whole, my 400. Okay, when it's a whole, we are multiplying, right? Of means we multiply. So I can do 70% times 400. Now, I don't really know how to put 78% in a calculator, but I do know what it is as a fraction and as a decimal. So you can either put 70 out of 100 times 400, and you can simplify, or you can do 0.70 times 400 in your calculator, and when you put that in, either way, you're going to get 280, which is the same answer. I think that this way is a lot easier than the double number line diagram in terms of there's just less steps, but the double number line is a really good visual to show you what's happening, okay? So those are the two different ways. Now I want you to pause, and I want you to tell me, answer both these questions here. What is 25% of $20, and what is 60% of 300? Go ahead and pause and do those. Now I'm going to go ahead and go over them. So 25% of $20, I'm going to do that short way where we can just multiply. Well, this is either going to be 25 hundredths times 20, which I can multiply by hand if I want to. This is going to be the same as 25 times 2 is 50, so this is 500 out of 100, which is just $5. Or you can put into a calculator 0.25 times 20, and you will get 5. Okay, so 25% of $20 would be $5, right? So if you were maybe going to leave a 25% tip, right, then you would be paying $5 as your tip. Now, what is 60% of 300? I'm going to do the decimal version this time. It would be 0.60 times 300. And when I go ahead and put that into my calculator, I get 180. Not too hard, right? Because we know of means multiply. Okay. There is another way that we're going to look at percents though. So in these cases, we knew the whole, right? We had the percent and we knew the whole. Now it's going to look different if we're given the whole and I'm trying to find, no, if I'm given the part and I want to find the whole. So let's look at the double number line diagram again. Okay, it says Carmen saved $27, which was 30%. Okay, so they're not saying 30% of 27. If they were saying that, then 27 would be the whole. That's not what they're saying. They're saying 30% is 27. So in this case, $27 is the part, okay? It's just the part, it's not the whole. That's really important because those are very different, okay? The way that they did this here with the double number line diagram was they said, well, for 30, right, I'm gonna break it up into 10 sections again. So they did, well, 30 divided by 10 is just 3, right? So then 27 divided by the 3 sections, wait, I got this backwards. I'm sorry. This should have been 30 divided, if it's going up by tens, right, then that's going to be 3 sections to get up there, right? That's my 10%, right? That's how they said break it up by tens. So if I do 27 divided by those 3 sections, that means that in each of those 10% sections, it's going to be 9. And that's where they got this right here, right? 10% is going to be worth $9. So every 10% now is going to be another 9. So this is really 18, 36, 45, right? I could go ahead and add 9 all the way up to figure that out. Or I could say my total, right, 100% is going to be 10 sections, right? 10% is how I'm going to get up to 100. I could also do my 9 times 10 rather than adding 9 10 times to get $90 is the whole, right? That's all of Carmen's earnings, the whole. The other thing you could do is when you're given the part and the 30%, remember how last time we multiplied to get the answer? Well, now we're going to do the opposite. Okay, this is the other way that we could do this. Instead of multiplying like we did before, now I could do my 27 divided by 30%. I'm going backwards, right? And the opposite of multiplying is dividing. But remember, we're not going to divide by a percent. I could do 27 divided by 0.30, or I could do 27 divided by 30 out of 100. Now, in that case, you would have to know how to divide fractions, which we're going to go over again next week, but you do know how to do that. Okay, if I put that into my calculator, which for right now I think is the easiest, I know that 27 divided by 0.3 is 90. You should have gotten the exact same thing. Either way, you're getting 90. Now, pause your video, and I want you to try this one on your own. 60% of the students at Kingsbury are Hispanic. Now, if there are 450 Hispanic students, obviously that's not all of the students. This is the part of our population at our school that is Hispanic. So I want you to tell me how many students are there at Kingsbury. Go ahead and pause your video now and solve for that. Okay, so you can either now do a double number line diagram, or you can do what we did before, right? If I have the part and I have the percent, 450 divided by my 60%, which I'm going to write as a decimal of 0.60. When I go ahead and put that into my calculator, I get 450 divided by 0.60 is a total of 750 students, and this is my whole, right? I solved for the total this time. That's very important. Make sure you label your part and your whole. It's going to help you a whole lot when you are working with percents. You guys are going to do great. You're doing awesome. Thank you for all the hard work you're putting in, and please reach out with any questions that you have from me.